Okay, so now we're going excuse me. Now we're going to the concept of what a, let's see if I can do this. A common denominator. So we're going to get into, what that is. Okay. And by far, this is, when you use a common denominator, it makes doing any sort of operation on the fraction, whether it's add, subtract, mult, or divide, makes it very, very, well, easy. And now this especially, I mentioned multiplication and division. Let's cross out for a minute. Especially when you're adding and subtracting, makes it very, very, very easy to do. And so let's go again to what a denominator is. Well, this is just the bottom number in a fraction. And it shows how many equal parts the item in question is divided into. So for instance, if you're adding, let's do 1/2 plus 1/3. Well, we don't know what to do with this, so this is more of like a, what do we do? Well, using common denominator, we're trying to find out, well, how could we add this? So what is equivalent to 1/2 and equivalent to 1/3, to where I can simply add these two? Well, if I multiply this by 3, right, I'll get 3/6. And if I multiply this by 2, I'll get 2/6. So notice I didn't change anything, right? So if I reduce this down, right, if I reduce the the 3/6 down becomes 1/2. Reduce the 2/6 down becomes 1/3. So it didn't change anything. I'm trying to make the denominators common or the same. So basically when we say common, right, same. So if I have, moving this forward, if I have 3/6 plus 2/6, I will get 5/6, right? And that is a much easier way, much easier representation than just trying to do just 1/2 plus 1/3, because you really can't get anywhere with this. And so that is clear this. And so the thing you want to know is, well, why? Why is this important? Why is this such a big deal? Well, in essence, before you can add or subtract, the denominators needs to be the same, right? So think of it this way, right? So we look at fractions like 1/2, 1/3, 1/4, 1/32, 1/16, ... Right? But now let's flip this. Well, why can we add numbers like 2 plus 3, 5 plus 6, 7 plus 1, and 8 plus 2. Why can we add all of these? Well, if you don't know, and most of you won't be familiar with this because you learn how to do whole numbers instead of fractions, instead of these fractions. So let's go use this. So let's look at this. 7 plus 1 equals 8. Well, why is this the case? Well, what is the denominator out of that? What gives us 7? Well, this is always, it's understood that we have this below, right? And so some of you might get confused and think, well, shouldn't it be 7 over 7? Well, no. So that's getting a bit ahead. That's getting to division, which this just equals to 1. But how many 1s go into a 7, right? And so you've dealt with fractions before, but, right, 7 times. And then 1 goes into 1, 1 time. Right? You've dealt with all these before, but now we're introducing it to you sort of on the flip side, backwards, which is why, I see always a lot of confusion. But yeah, these whole numbers are also, you could say, fractions as well. So like 2 over 1 plus 3 over 1. But because, these are a whole number, right, we don't necessarily have to, keep the one. So let's go back to clear this. So let's go back over to like 5 over 2, right? So you could write it as 5 over 2, but this also equals 2 to the 1 half. Now you see what we did there? So we essentially divided this, right? So you had 2, right? This goes 2 times, simple division minus 4. So you had 1 remaining, right? Which is essentially half of the 2 value. So that's why we have 2.5, right? And if you multiply this out, right, and I'm sure you're aware, if you always start with the denominator, right, and then you add the numerator. So 2 times 2 is 4 plus 1 is 5. But we're trying to express this in terms of halves, so that's why we always keep the denominator 2, right? And so what I've just shown you here is kind of a cross check. But this is just giving you a feeling, giving you an idea of why we need to have a common denominator, which is what nobody really shows you. Shows you the beauty of how all these fractions and numbers, of how the fractions is actually an intricate process that works together when you multiply and divide. But essentially now you know why you need to have a common denominator, why you can't just do 1 half plus 1/3. It doesn't make any sense. Think about if I were to flip it to like 2 over 1, and these are completely different examples. So this one does not equal this one. But if I were to flip it to 2 over 1 plus 3 over 1, yeah, you have a common denominator. And so definitely you can add these to 5 over 1. But we know it's implicitly understood as 5. And so if you need the if I give you the proof, no, the proof is going to confuse you. But in the next lesson, I think this is enough to give you an idea of what to do. But in the next lesson, instead of talking about the common denominator, I'm going to talk about the least common denominator. Least common denominator. And I've already given you kind of a preview of that. And so basically what we're trying to do is we're trying to say, well, I have 6 over 2 is my final answer, right? But then if you're dealing with real world problems, especially when you get into computations or computer programming, which tends to use a lot of these things, you want to go with the least because it takes up so much resources to, have these big fractions. So, 6 over 2 is equal to 3, and that will run quicker from a computer program sense rather than having the 6 over 2 value. So you're always trying to get to the least amount, essentially because you're trying to use up less resources. But I'll get into that more in the next lecture.